Alright, so let's have a look at this shape. And this shape is clearly an arrow. Now, what I'm doing is I'm just marking my edge so I know exactly where it is. And I will call this the original shape. This is where it exists. So I'm holding it down and I'm just marking off the edges. And what I've done is I've taken a pin and I've poked a pin through the paper, and I've taken a small piece of cardboard to poke the pin into. That way the pin stays in place. Now the pin represents the point of rotation, or the center of rotation, on the object. So it's actually a part of the object here. Now if the question states that you have to rotate your object 90 degrees clockwise, well, on our paper we can pretend that this is a clock face, and 90 degrees clockwise, well, which direction do the hands move? Clockwise would be this way. That means if we finish the movement of our clock hands, they're going to go this direction. So if it was 90 degrees clockwise, we'd have to take our shape and move it this direction, meaning this is going to be the leading point. So if this corner is the leading point, we have to make sure that this could be our edge that we mark. So if that's the edge that we mark, we need to take that arm and move it 90 degrees this way. And we can use a protractor to actually mark out our 90 degree angle. Or we can just rotate just like that. And this is a 90 degree rotation, and this would become our image. So our image is what we get after we rotate. It's not the original. It's actually the new position of our original. Now if I slide back, you can see that this is a 90 degree rotation. So this would be our image. Lowercase I represents image, and this is the actual object, O. So that's a 90 degree rotation. Now if I want to take my arrow and actually turn it or rotate it 180 degrees, now either way, it doesn't matter which way I rotate it. If I rotate it 180 degrees clockwise, my arrow is going to be pointing down. And if I rotate it 180 degrees counterclockwise, my arrow is still going to be pointing down. Sorry, I'm just going to reset my pin. If I go back here, now if I rotate 180 degrees counterclockwise, again 180 degrees counterclockwise, pin keeps coming in. Anyway, but the arrow is upside down. So how would I rotate 90 degrees counterclockwise from my origin? Let's reset it and see what it might look like. Okay, so I'm going to mark my pin in position. Now 90 degrees counterclockwise. Well, if these arrows are showing clockwise, the movement of the hands on an analog clock, counterclockwise would be in the opposite direction, meaning my shape is going to move this way. That means this is my leading edge, so I can mark my leading edge 90 degrees. This is my vertex, where the point or center of rotation is, meaning this arm has to go 90 degrees this direction if I'm going to do a 90 degree counterclockwise rotation. And I can mark that with my protractor to make sure it's accurate, finish my rotation, and I can redraw my new image. So I hope this helps you work on or describe or model using a pin, a cutout, the clockwise, counterclockwise diagrams to try and show how you would do a rotation about a point on an object.